Okay. So I started recording it just now. But anyway, so you understood that when we heat, it doesn't mean that we are starting the reaction with oxygen. For decomposition, we just need to heat it, and that heat will break it down into different compounds. But when we were burning the magnesium ribbon in oxygen, we were studying what happens with the reaction with oxygen. So we were not just giving heat to it. We were completely burning it in presence of oxygen. That is why you had magnesium plus oxygen over there.
Okay, sir.
Okay, now you need to remember one thing, that the lecture number in science and maths has become separate now, because in science we are doing 15th lecture because we had cancelled one of the science classes, and maths is going lecture 16. Okay, so don't get confused with that. Just keep them separate, your things. Okay, so this is lecture 15 for science today. All right, so let's discuss a few more things about the first chapter before I go into light. I will start the light chapter today. Towards the end of the class, I'll just give some basic introduction, and then we will start with the whole chapter tomorrow thoroughly. But let's do some questions based on the first chapter. Okay, I want all of you to quickly write down the name of all the different types of reactions which we studied. Write it down in your tuition note. Or let's say tell me when you're done. So if you don't remember, it's okay. You can go back to your notes and check it out. But I would expect you to remember these names by now, okay? If you have not remembered it already, make sure you remember all the names. Try to remember as many examples as you can and practice them, okay? And also remember the colors of things, which is the products or whatever. It gives out some color sometime, right? So remember those colors also.
And sir.
Okay, good. Is everyone done?
Yes, sir.
Tell me, what are the names?
Combination, decomposition, displacement, double displacement, oxidation, and reduction.
Okay, very good. And decomposition reactions we studied?
Exothermic and precipitation, sir.
Thermal, electrolytic, and photolytic.
Yes, yes. And precipitation reactions also we studied. That the lot of examples which we saw as a double displacement reaction, they were also precipitation reaction because some kind of precipitate was formed in them. Exothermic reaction also, Ritesh, that's correct. But exothermic reactions are any reactions which gives out heat. So that way, if we study, we will have to study endothermic also. Endothermic, which will absorb heat for a reaction to happen. As part of a reaction, the heat is absorbed in endothermic reactions. Exothermic reactions, heat is released. Okay, but based on what's there in your NCERT book, yeah. So the main important names what we studied is combination, decomposition, displacement, double displacement, oxidation reduction. Just give me a second. Okay. So you will write down the balanced chemical equation for this one. Write down their symbols if you remember and try to balance the equation. Okay, so whoever knows should be done by now. What is the symbol of zinc?
Zn.
Zn, sir.
Zn. What about silver nitrate?
AgNO3.
Yes, nitrate in general, you should remember that nitrate will be NO3. Remember, don't write N and small o. It will be N capital O. Nitrogen and oxygen with 3. This is your nitrate. Okay. And since it is a silver nitrate, it will be AgNO3. AgNO3. And this gives zinc nitrate. What will be the formula for zinc nitrate?
ZnNO3, sir.
Yes, it will be Zn and NO3.
Whole 2, sir.
Yes, nitrate will have a whole 2.
Sir, then this side also zinc should have 2, no, sir?
We studied about that now. That different compounds are formed by different number of atoms. Like hydrogen combines with water, 2 atoms of hydrogen combine with 1 atom of oxygen. But one single atom of carbon combines with 2 atoms of oxygen. So you should not say that I should write C2O. Just because it is H2O, does it mean that it will be C2O? No, right?
No, sir.
Because H2O is a different compound actually. So just a minute. Let me check.
Sir, I'm asking that the zinc valence is 2, no, sir? So on the left hand side, why can't we write that 2?
No, zinc metal will exist as zinc itself. It's not like the formula for zinc is not Zn2. Is that what you're asking?
Yes, sir.
Yeah, no. So zinc exists like zinc itself. The formula for zinc is not Zn2. Zinc metal exists like Zn itself, okay?
Yes, sir.
All right, so yeah, so zinc nitrate and then silver will be of course Ag. So is it already balanced?
No, sir.
It's not balanced.
No, sir.
So what should I do?
Add 2 in the left hand side for silver nitrate, sir.
Okay, so if I push 2 here, then nitrate will become 2. This part is satisfied, very good. But in doing that, we change the number of atoms of silver. So silver has become 2 now.
So in the reactants, we have to add 2. For
That's
silver.
why in the reactant, we will add 2. So now everything is happy. Zinc 1 atom here also. Nitrate 2 atoms. Here also 2 atoms of nitrate. 2 whatever. It's not a single atom. Nitrate is not a single atom actually. It's a radical. Anyway, then 2 atoms of silver. Okay, good. Everyone is comfortable with this kind of a thing?
This is a displacement reaction, sir.
Yes, it is. So zinc went and displaced silver, right? Zinc took the place of silver. So this is also an example of a displacement reaction. Okay. Now I will write some reactions and you will have to tell me what type of chemical reaction is represented by that. Okay, what kind of chemical reaction is that? So let's take the first one. Yeah, tell me.
Decomposition reaction.
Yes, one single compound broke down into 2 of them. So it's an example of a decomposition reaction. Everyone got that?
Yes, sir.
Yes. What about this one?
Displacement reaction.
Yes. Is that correct? Everyone got that? Mg is going displacing the copper from there. So it's a displacement reaction.
double displacement, sir.
Yes, very good. What's happening here? Copper is displacing sodium and sodium is displacing copper. So sodium goes and makes this sodium sulfate, and copper makes this copper hydroxide. Right, so this is double displacement. Did we study this third example as part of our examples which we had taken earlier for double displacement?
No, sir.
That's okay. So I think you people are comfortable now. Let's take some oxidation reduction example also, and then we'll be done with this. Okay, so I will write a reaction. You have to tell me which compound is reduced, which compound is oxidized, which is the reducing agent, which is the oxidizing agent, everything, all the four answers you'll have to give. Okay, so yeah, so this is your reaction. You have to tell me which compound is getting reduced and which is getting oxidized.
Sir, PBS got oxidized, sir.
Okay, so Manoj says PBS got oxidized to what?
PDSO4, sir.
PBS is getting oxidized to PbSO4. Okay, what would be the name of this thing? PBS means what?
Lead sulfide, sir.
Yeah, PB is lead, okay? LEAD, lead. We read it as lead. So this is lead sulfide, and that becomes, what is this compound? What do you think it will be? SO4 means what?
Sulfate.
Yes, SO4 means sulfate. Everybody knows that. Like I said, NO3 is nitrate. Same way, SO4 is sulfate. So lead sulfate.
Sir, is there SO3?
SO3. Yes, there can be compounds with SO3, I think, yes. But I will check that, I'll confirm, okay? like I said, I don't always know everything in chemistry. So I only know things which you need to study. So I will check that whether I think SO3 is also possible, but I will check it out. Okay.
Yes, sir.
Okay. So let's yeah. So this compound is got oxidized. Why? What is the reason for that?
Oxygen is added, sir.
Okay, very simple. Oxygen is added. So oxidation is happening here. So of course the other compound, whatever is there, that would have got reduced and reduced to what? Of course to H2O. And what happened here?
Removal of oxygen, sir.
Yes. Very good. It had O2. Now it had become O only. So one of the oxygen atoms was removed from there. So it's removal of oxygen, and which we know as reduction. So which is a compound that oxidized? Lead sulfide. PBS was oxidized, and H2O2. Anybody knows what is the name of H2O2? H2O everyone would have heard. What is H2O2?
Hydrogen peroxide, sir.
Yes, hydrogen peroxide. Very good. H2O2 was reduced. So tell me which is the oxidizing agent and which is the reducing agent here?
Oxidizing agent is hydrogen peroxide, sir. And reducing agent is lead sulfide.
Yes, whichever got oxidized, that is the reducing agent. Whichever got reduced is the oxidizing agent. So PBS got oxidized. Why? Because of H2O2. This is the guy which gave the oxygen for oxidation. And H2O2 got reduced. Why? Because PBS came and snatched the oxygen from there. So PBS becomes the reducing agent. Okay. Same way, identify which is where is oxidation happening, where is reduction happening in this one. Everything, all the 4 questions. H2S plus Cl2 gives you sulfur and 2HCl. So what is happening? Tell me.
Sir, H2S is reduced to oxidation, sir.
Okay, is that correct? H2S2S. Ritish said it is oxidation. Is that correct? Guys, do you agree with Ritish?
Yes, sir.
Okay. Why?
H2S changes to HCl because addition of non-metal, that can also be there, sir.
See, H2S is there, no? So chlorine is not added to H2S. If it was H2H, hydrogen was also there, sulfur was also there, and then chlorine was added, then you should have taken that condition.
Okay, sir.
Okay, but you see H2S is there, two things are there, hydrogen and sulfur, and here only sulfur is there. So this is straightforward. No, hydrogen got removed from here. Make sense, everyone? So
Removal of hydrogens.
yes, this is removal of hydrogen. That's the reason for it. And when hydrogen is removed, we call it as oxidation.
And for reduction, addition of an non-metal.
No, not even that. We don't even have to think about that. See
Addition
here,
of hydrogen.
Addition of hydrogen.
chlorine is here, but chlorine has got somehow magically hydrogen has appeared. Hydrogen has got added to chlorine, right? So addition of hydrogen. Removal of hydrogen and addition of hydrogen. So removal of hydrogen is oxidation. And okay, I think I used different color combination. I always use this, right? So let me use the same thing. Removal of hydrogen is oxidation, and addition of hydrogen So answer the 4 questions. Tell me, which compound got oxidized?
H2S.
H2S. I need answers from everyone, guys. Try it. Even if someone has answered, if you remember it, just speak up right away. I will know how many people have spoken. I will recognize your voice, okay? So even though I don't take your name, at least I will know that you have understood this. So don't, if someone has answered, don't wait. You still tell me your answer, okay? I need answers from everyone. It's okay to shout out at all of you at a time. If I don't understand, I will ask you again. Yes, so which is the compound which got reduced?
Cl2.
Yes, Cl2, that is our chlorine. Yes. Which is the oxidizing agent here?
Chlorine.
Yes, the compound which gets reduced is our oxidizing agent. Okay, and then reducing agent, of course, what is it?
Hydrogen sulfide.
Yes. Excellent. Very quickly, tell me, what's the compound getting oxidized, reduced, whatever it is?
Sir, SO2.
Sir, hydrogen sulfide is oxidized, sir.
Hydrogen sulfide is oxidized. Is that correct?
Removal of hydrogen, sir.
Okay, earlier it was H2S, and here it is only sulfur. So hydrogen got removed over here.
So that is oxidized, sir.
Hmm. And what got reduced?
SO2 is reduced
SO2 is reduced to what?
to sulfur.
To sulfur again. Yes. Here it was removal of oxygen. Here it was removal of hydrogen. Okay, so let me write it like how I always write. So H2S, 2S, this is our oxidation. The reason is removal of hydrogen. See, this might be confusing. You might be thinking something should have got reduced to H2O, but that's not what is happening. Because like I said, we can't take either oxygen or even this to H2O because none of the compound is alone over here. Here you have SO2, here you have H2S. In both these cases, we have sulfur as the common thing, and the sulfur is over here, which we saw that here hydrogen got removed. And in this case, oxygen got removed. So this makes more sense to understand that this is oxidation. And this one is reduction. What is the reason here? Removal of oxygen. All right, so tell me the names of things again quickly.
Hydrogen sulfide got oxidized, sir.
Okay. And oxidizing agent will be this, of course. H2S will be the reducing agent. Is that correct?
SO2 is called as sulfur dioxide, sir.
Yes, sulfur dioxide. And remember, SO2 is a separate compound. It exists freely on its own. Not that SO4. SO4 cannot exist on its own. Okay, this is sulfate radical. It has to be combined with something else to be able to exist. Okay, just like
Sir, then the symbol for sulfuric acid, sir.
sulfuric acid, H2SO4. When that sulfate thing combines with two atoms of hydrogen, this is what you call it as your sulfuric acid, H2SO4.
Okay, sir.
Okay. Okay, so that's it, guys. And I had asked you people to write down the answers for the NCERT questions. How many of you have done that?